All right, good morning. We will start the lesson shortly after 1 minute. So please be prepared, and we will have a coverage on the recap of concentration. The questions on page 36 and 37. So you may turn on the camera, and we will start the lesson shortly. Anyone who see 火燒王 not here. 火燒王 So as said before, you are going to have a checking of the answer of practice practice 37.1. Please take a look. 37.1 here. Okay. I repeat, 火燒王 not here. Okay, we will start the lesson right away. Now, 37.1. We have got the coverage of concentration in the supplementary lesson last time. So let's check the answer for question 1. So you are going to have this reaction again between X and Y, while when X and Y is added, the cross will start to become blur and finally become totally invisible when viewed from the above. So you are going to mark the time when the mark cross to be blotted out. And here comes the trial 1, 2, 3 with different volumes of X and Y and with different time. Of course, volume water will also be considered. So what is the effect, if any, of increasing concentration of X on the rate of reaction and the increasing concentration of Y? What is the rate? How will be the rate of reaction be affected? You understand? Now, you may find it challenging, right? So how you tackle the problem? How you tackle the problem? Right, is to find out the pair of the two sets of experiments in which you can get to know there's only the change in concentration of X. Is for A And for Y, for B part, if you are going to find out the varying concentration of Y, what is the effect on the rates of reaction, you are going to find another pair. Do you understand? So, for example, X, you are going to, I start from this one, you are going to compare trial what and what, and you can get the answer for A. For B, you do the same. You compare trial what and what, and you can get the answer. Do you understand? Do you understand the whole flow? So I would like to ask Deng Hou Yu. For A, what will you do to this to compare the two sets of experiment? What two sets?
Trial 1 and 3.
Trial 1 and 3. So what is the difference about that? You are changing the concentration of
X.
X only. Yes, X only. So my question is, how come the volume of water change? Is a fair test? You just said the concentration of X is changed right from the volume, but I can see the volume of water also change. So is it still a fair test or not a fair test?
Yes, because the solution mixture is still 30 cm3.
The total volume of the solution is still 30. Okay, so what is the significance? So why do we need to insist, right, on making the total volume the same? What is the reason behind? But it seems that water it adds up a final touch on that, such that the volume of it will be adjusted so as to make the total volume constant, right? So the reason, I would like to know the reason. Why is maintaining the total volume of a solution being the same so important? Now go back to trial 1 and 3. Can you tell me the independent variable, dependent variable, and control variable in this?
The independent variable is the volume of X.
Volume of X.
The controlled variable is the volume of Y.
How about volume of water? Now, do you understand? So that is rather problematic if you write down volume as a variable. Also, I change a little bit about the wordings, and the whole thing can be solved in an easier manner. Gia Jing, what do you think?
Yeah.
Yes.
Yes, what's his question? I can't hear.
My question is the independent variable and control variable dependent models, right? Indeed. So what Deng Hou Yu has been said is the volume of X and Y respectively, but it will be rather problematic. I just asked them, how come the volume of water is not the same? So what's the point? What's the point of adding the different volume of water?
To make both solutions have same volume.
Yes. So my question is, what is the significance? So why is it so important? Why is the maintaining of volume of solution mixture constant so important? Why does that assurance so important? Do you understand? Do you understand my question? Sorry to say that I need to plug in the notebook with the power on. Yeah, I take another seats here. Now, see what do you think? I adjust that two statement a little bit. See what again? I not use the word
Number of moles.
number of moles. You write the number of moles is different. If you say that the number of moles has been, one of them is changed. Now this one is changed. This one doesn't change, but you still need to keep the total volume constant. Okay, so you have to go back to the question itself, right? The concentration of X, how does it affect? So the answer, it is concentration, but not number of moles, right? Because the total volume is now the same. It's now already the same. So it is a convenience sake. Only by merely checking the change in volume of a solution would you directly relate to the fact that the concentration has also been changed. Do you understand? So this is for convenience sake. But in the presentation, while you talk to the others, so what is the independent variable in the experiments? So go back to the factor to be studied. The factor to be studied, finally, what you're going to have is to want to get to know how the concentration of X changes would affect the rate of reaction. So the answer is concentration of X. Because of that, I keep the total volume of solution constant. So for Y, I mark the volume the same. What is a hidden message? The concentration of Y remains unchanged as well. So remember, keeping the total volume of solution mixture that it has its meaning behind is to keep all other factors the same. Okay. Otherwise, what will happen if somebody is too lazy? Mr. Chin, I have adjusted the volume of X. I've adjusted the volume of Y already. Now, even though I keep Y, the volume of Y the same, for example, A and just take a look on 1 and 3. Can we say that you are studying how concentration of X affect the rate of reaction? The answer is no. Can you get my point? Now, if I cross out the volume of water, the column here, what will happen? What is the total volume of solution for that two cases? The first one is 15.0 cm cube. For the second one is 20 cm cube. So you want to talk about concentration of X being the independent variable. Of course, it has got to change. However, when you want to talk about control variable of Y, okay, the concentration of Y is not the same. Is the reason behind is that you are going to make a dilution by mixing the two solutions at the very beginning, right? But for the third case is just a 2-time dilution. While for the first case, you just diluted by 5 cm cube of X only. So the total volume being 15.0 cm cube, which means that the concentration of Y has been changed. Can you get my point? Even though it's because of the fact that the total volume of the solution has been changed. So it's not a fair test. In short, it is not a fair test. So keep the volume of water must be adjusted in line with the volume X and Y added, so as to keep the whole volume the same. Can you get my point? Only by doing so, you can say that the control variable really kept it constant. Otherwise, it's not constant. It's not a fair test. Do you understand? So you know the significance of adding water. I've just told you that one in last time in the supplementary lesson. So yes, correct. You are going to compare trial 1 and 3. So quantitatively, could you please make a relationship of the data trial 1 and 3? Quantitatively, tell me. Oh, Hin.
Hi.
Yeah. Comparing trial 1 and 3, please continue the statement.
Volume of C is larger than 1, so concentration of 3 is smaller.
Volume of X changes. How change? What is the change? What is the change? Now, indeed, that is the difference between Form 1 and Form 4. You are going to tell it to be more exact, quantitatively, how. So please check. But I said before, you are not going to compare the volume. Instead, you are going to compare the concentration of X as written into the ebook. Do you see that? Could you please say it again? How does the concentration of X affect the rate of reaction?喂，做咩輕咗嘅？冇聲喂。
Yes, yes, yes.
係，即係點啊 ？Quantitatively 啊 ，which means that you are going to tell me in figures, but not tell me one is increased, one is decreased. You just tell me qualitatively. Call the qualitative analysis, but I need quantitative.
Higher the concentration and longer the time taken.
The higher the concentration of what chemical?
X.
X. Yes. And then the time taken for the back cross to be plotted out is
Longer.
Longer. So which one? Trial 1 and trial 3. Which one would have a higher concentration of X? Trial 1 or trial 3?
Trial 1 have higher concentration.
Trial
Of
1
X.
has a higher concentration of X. How will you know? How will you know? From the volume of X added, is it? This?
Yes, yes, yes.
So which you mean that 5.0 cm cube has a larger volume than 10 cm cube? Do you mean that?
Yes.
5 is greater than 10.
No.
You just said that. Okay, we have got witness of a whole class Chem 1 student. Okay, please cap the picture and post it into an IG story, instant story. Okay, remember to tag his name. Okay, 5 is greater than 10. Okay, 5 is greater than 10, such that you just tell me trial 1 has a higher concentration of X, so that you find that the longer the time it will take them. Right? Agree? Lekin Ho, you just laugh, that which means that you know the answer. Tell me what is it? Is it the case? Tell me your thoughts. Trial 1 and trial 3. How does it compare?
Trial 1, the volume of X is smaller than the trial 3 of the volume of X.
So the concentration of X varies. Trial 1 is smaller, trial 3 is larger. So how does it affect the time taken?
The concentration smaller, the time taken is shorter.
When the concentration of X is lower, the time taken for the mark cross to be plotted out is shorter. You mean that? Oh, that's why. Okay, that's why you two are brothers. Chen Yu.
Yeah.
I just want to get consistent result from Chem 1 class, okay? Because of the time limitation, I cannot do the sampling of all. I just pick up 3 samples, okay? If I still have got the same answer from you, which means that I have made a valid conclusion. Am I correct?
Yes.
Yes, really? You want to tell me the same? Is it?
Is the higher the concentration of X, the shorter the time it will be taken.
Yes, that's right. The higher the concentration of X, the shorter the time taken. Now, take a look on X and 3. Suppose I have got a jump from this. So we have got a change in concentration of X, right? So what is the change? What is the change? How many times more concentrated is this? Now, what you just mentioned is just qualitative statement. I need quantitative. What is the change in the concentration of this from 5 cm cube to 10 cm cube? Chen Yu,
Yes.
the double it is the concentration.
I think yes, because the number of moles is double.
Yes, the number of volts is double. Double of volts is double, while the total volume is the same between 1 and 3. So what is the change in concentration when you compare from 1 to 3?
The change in concentration is also double.
Yes, it is a double concentration. Can you get my point? So that's why you are for this one. I can also say it like this way: when the concentration of X is double. Can you get my point? So how about the time taken quantitatively? It will be
half.
Yep, it will be half. It will be halved. Can you get my point? The one written in red, it will tell you quantitatively from numbers how does the concentration exchanges. But how do we relate from time to rate? From time to rate. Yesterday I just give you one statement, a very important statement. How can you relate the rate and time? Can you please continue?
How the rate is, the rate is higher if the time is taken shorter.
So what is the mathematical relationship between rate
Rates will alpha the 1 over time.
and alpha and then 1 over time? So what is meant by 1 alpha 1 over time. I use a very important statement to tell. What is that? What is that in mathematics? What we call it?
Is the inversely proportional.
Yes, that's right. It is an inverse proportion. So you will tell it is inversely proportional to the rate is inversely proportional to the time taken. And so that is the second statement, because the rate it is inversely proportional to the time taken. So according to our statement, so you may get it as a conclusion. So the when the concentration of X is double, the rate will be, how does it affect the rate? Now you check the time is halved, right? When you come from 1 to number 3, trial 1 to number 3. So what does it mean by the rate?
The rate will be doubled.
Yep, good. The rate is doubled. Can you get my point? So the quantitative statement to relate them is the concentration of X is doubled. The time taken for the macros to be plotted out will be halved, which means that the rate is doubled. Can you get the point? So this is the mathematical relationship between concentration of X. It affects the time taken while it affects the rate. In case it's double, it is half. So the rate is doubled. All of you, please mark it down. Do you understand? So the arrow, they will tell you the logical sequence. You do the same thing to try out B. Okay, Long Mai Hian. Please use the same logic to try out B. To compare, to find out the effects of the concentration of Y on the reaction rate. So what 2 trials would be chosen? Long Mai Hian.
Trial 2 and trial 3.
Trial 2 and trial 3. Please take a look. Trial 2 and trial 3. 2 and 3. 2 and 3. So what is the independent variable?
The concentration of Y.
Concentration of Y. Now concentration of Y changes, is it?
Yes.
Okay, how about concentration of X? They should be changed, or they should be the same?
They remain the same.
They want to remain it the same, but take a look on that. And other big, how are they talking about the same concentration of X? 2 and 3?
Maybe not.
Maybe not. 5, is it equal to 10?
No, of course not.
So you just mentioned 2 and 3. I give you one more chance to choose trial again.
Trial 1 and 2.
Trial 1 and 2,
and 2.
correct. Trial 1 and 2, correct. Okay. Chem 1 student, don't tell me. We have just come up with 2 big discovery in mathematics. One, the first statement is 5 is greater than 10. The second statement is 5 is equal to 10. Okay. But that 2 statement is our big discovery. But that 2 sentences, you want to make it true always. So my question is, that 2 statement is exactly contradictory. Crazy. Aye. Now, Mai Hian, could you please continue the remaining part?
When the concentration of Y is higher, the time taken is remain the same.
The time taken. Again, for the macros to be brought out remains the same. So what is the hidden message? Now, so you just tell me the time only. How about rates?
We see the concentration.
How does the rate related to time? They are in inverse proportion, right?
Yes.
In case the time is not has not been changed, how about the rate?
The rate remain unchanged.
Yes, the rate remains unchanged. So, can you tell me the very important statement to tell us the increasing the concentration of Y on the rate? What is the relationship between the two? What is the relationship between the two?
When the concentration of Y is double, the time taken is remain unchanged, and thus the rate is remain unchanged too.
Yeah, so what is the relationship between changing the concentration of Y and the rate? What is the relationship?
The change in concentration will not affect the rate of reaction.
Yes, exactly. So there is no relationship. Can you get my point? I keep on
Okay.
asking what is the relationship. The answer is no relationship.
Okay.
Can you get my point?
Yes, again.
Okay, so there is no relationship. And what you just said is a final sentence is also correct. The concentration of Y does not affect the rate of reaction. Okay, can you get my point? The change in concentration of Y does not affect the rate of reaction. So you simply tell there is no relationship between the concentration of Y and rate of reaction. Very strange, isn't it? Yes, that is the fact. You can have some cases in which irrespective of the change in concentration for certain reactant, the rate of reaction still doesn't change. Okay, so there is some reason behind. We will know it in industrial chemistry in Form 6. But mathematically or experimentally, we will also have got such a chart in which I change the concentration of one reactant and the rate of reaction hasn't been changed. There are some cases, and while the case it is not so rare to see such. Do you understand? So this is a very important conclusion to tell while you study the some factors affecting some phenomenon. For example, you may think some factors play a role. Okay, after doing experiments, you may find that it has or it doesn't have. It's also acceptable. You're going is used to by doing the fair test, it helps you rule out some other possibilities and to direct to the answer. What are the main factors affecting the rate of reaction? Can you get the point? So it's very common. So don't get too worried that you finally have a conclusion that no relationship. It's common. It's common. Do you know it? In the university thesis 論文啦. So some scientists they will try hard, they're very hard and try to find out some related factors to be studied and try to pick it one by one to have a further analysis. Okay, it's very common. It's very common. So don't get too surprised if you find the conclusion being no relationship. It's normal. Question 2. Any questions so far? Now, question 2. The student compared the rate of reaction of magnesium with hydrochloric acid and propanoic acid at the same concentration. The magnesium was in excess in both trials, and the student measured the volume of hydrogen released at regular time interval to show this graph. For A part, state 2 factors that will be kept the same, kept constant. So they are asking for what controlled variables in this experiment, in the true trials for the fair comparison, fair test, right? So again, so what should be it be like? And James. Zhao Zheng, could you please suggest some controlled variables?
Concentration of hydrochloric acid and propanoic acid.
Concentration of, yes, mentioned. They are mentioned in the question. So the question is a rather problematic, because if I were the marker, I will have a set of a question. I will write down state 2 other factors, okay, instead of merely finding it into the questions. Besides concentration of acid, what else can you think of? Can you please give me one more control variable?
Temperature of hydrochloric acid.
Of what?
Hydrochloric acid and propanoic acid.
Okay, the temperature of the acids. Good. What else? Can I have some other students for help? I check your last list. See the one here.
The volume
Volume of what?
of the acid.
Volume of acid. Now, volume of acid, it is used to tackle this part, okay? But for the concentration of acid, temperature of acid, you are going to mention something about this part, okay? What else? Can you think of one more? How about the blue one? Now, why do I insist of asking the blue one? Because the question, the purpose of the question is asked for the rate of reaction to be studied, depending with different factors changing of it. Anyone who can think of one more? How about the solid? What solid are you using? Can you think of some of the physical appearance of a solid?
Surface area of magnesium.
Yep, good. Surface area of magnesium. Now, good. Surface area of magnesium. So what is mean by surface area? You may mention it as particle size as well, right? The smaller the particle size, the larger the surface area. Do you understand? That how big or how small the particle it is, okay? If you have got smaller particle, you have got larger surface area. So also they will affect the blue one. But once you talk about the mass of mg, what you just mentioned, it will be the same as volume. You are going to control the final outcome, the volume of a hydrogen being the same, finally. Can you get my point? So if you write down the two control the variables in order to study how does the rate of reaction be affected, you may mention it on the left-hand side. Firstly, okay. How about B? The two curves have different shapes because the strength of each acid is different. I mentioned the strength of each acid, which means that the strength of the acid, it is our independent variable, isn't it? Right? Is, of course, you may write it as type of acid, but the type of acid is problematic. You change it to independent variable. Write about the difference between a strong acid and a weak acid. Explain why the two curves are different. Write about the difference between strong and weak acid. Explain why the two curves are different.
Strong acid and an acid that completely ionize in water to give hydrogen ion, while a weak acid is an acid that partially ionize in water to give hydrogen ions. So since hydrochloric is a strong acid and propanol acid is a weak acid, the concentration of hydrogen ions of HCl is higher than that of propanol acid. So that the initial rate of the reaction between HCl and magnesium is higher than that of propanol acid and magnesium.
Correct. Okay, quite nice. Okay, so we have got to the explanation in acid and alkali, right? To tell. Go back to acid and alkali, that chapter. So you just mentioned HCl being a strong acid, so which means that it fully ionizes in water to form hydrogen ions, while for the other it is the weak acid, propanol acid. So with formula CH3, CH2, COOH being a weak acid. Okay, so we have got a slightly ionizes or completely ionizes in water to form hydrogen ions. Wow, you would say the concentration of acid being the same, here comes the difference, is the concentration of hydrogen ion be in these two cases different. For HCl, it is higher. The propanol acid, it is lower. Okay, so you are going to compare the two. So you may find it what? From the graph, go back to the graph. How will you know that the HCl will have a faster rate? The curve is steeper. Okay, so which means that the rate of reaction, it is what? Is faster or higher. Okay, the rate of reaction is higher, so the reaction itself is faster. Can you get the point? So HCl, it is higher than, with a faster reaction than propanol acid. Do you understand? Do you understand logical flow? So in short, the logical flow is the concentration of hydrogen ions that would affect the rate of reaction. Okay, while this one, concentration of ions, it is affected by the strength of acid. Can you see the flow? So from this question, here comes the logical flow. The strength of acid affects the concentration of hydrogen ion. Of course, you may soon find that the concentration of hydrogen ion will also be affected by the temperature, as well as the concentration of the acid, and also basicity of acid as well. Do you understand? So if you want to be more exact, these three factors should be kept the same, which means that you are going to make them a control variables. Do you understand? You're going to make them three factors the same so as not to affect the concentration of hydrogen ions. By doing so, whenever there is a change in rate of reaction, you can directly rule out some other possibility and say for sure that that is due to the change in is the strength of the acid. But the strength in of acid plays a role in affecting the rate. Is that clear? Is that clear? Okay, for those who understand what I've just said, could you please put a tick, if not across. Now this is what you may need to be highly aware of. Otherwise, you may find the whole case rather problematic. Now, first, do you realize that I just done it very slowly? I just do the explanation very slowly here. I need to check if you really understand. About 何本靜, do you understand? 李敬浩、吳家靜、冼俊琪、黃清華, do you understand? Do you understand what is really happening? Okay, and Wu Hin, do you understand? So Lei King Ho, tell me your concern about this. Now, please make sure all of us are ready before we proceed. What's the concern?
The A part that mentioned the surface area of magnesium. That's why don't use the surface area to the volume of magnesium. That can compare to the magnesium that we had.
You mean the physical quantities of magnesium? You want to keep the same, or what? Could you please repeat your questions?
That means the magnesium would react to two acids, but if only the surface area is controlled, but the volume is not controlled, that means the surface area to the volume ratio is not controlled. Therefore, the reactant is not the same. That maybe affect the rate of reaction.
The reactant may not be the same in terms of what? In terms of rate, you just argue if it really affects the rate. Do you mean that? Now, for this question, anyone who can answer this stops. Now, indeed, what is the we need to go back to how the reaction goes, how the reaction happens is by collision theory. Okay, so you may find this concept in the later pages, which is page 45. Now, in order to answer the whole stuff, please take a look on page 45 of your ebook or your textbook. So if you want to talk about the reaction that will happen, at least we need to have a collision of reactant particles. So in your case, we talk about magnesium and the acid. in particular hydrogen ions. Okay, so we have got 7 different cases. Okay, the first one is to talk about the orientation, the direction of heating. In case the direction of heating is not correct, even though the reaction will not go. So you may find the 2 chemicals, the rebound with the same chemical. Can you see that? The same chemical form can be seen. How about the second one? If you are going to have a good orientation, the best orientation, but the energy is not enough. What I mean is the KE, the kinetic energy is not enough. What will happen? So in just like this case, the correct orientation, the correct angle of heating, but they will bounce back to form the 2 to give the original chemicals. So the reactions will still do not go. How about the third case? We only by having the same orientation with sufficient energy, which means the sufficient KE, they are fast moving enough so as to make the bonding happen like this way. Could you please see that? Okay, enough energy that will help break the bond, and for example, they will form the bond naturally. And you may find this one, the product. So check that product is different from the reactant. So which means that the reaction is set to be undergone successfully. So we will call this type of a collision an effective collision. So go back to the question itself. Once you talk about the Mg, okay? So the Mg plays a role only on the surface, okay? Only on the surface. So you take a look on the ebook page 48 and you can get what it means. Why do we need to insist to say that the surface area of Mg is so important in this reaction? Because if you have a larger surface area just like this, so you may have got some extra surface area like here, okay, like here, this part, and this part, okay? When you compare with the big one, so you may think of it as something like a fragment of that. Okay, can you get my point? If you treat it as a fragment. So this meeting surface here will be more than before, okay? After breaking it down. So we will have a more surface area to get into contact with the exit. So remember, even though the exit will be of larger volume, okay? As long as it is not close to the surface, to the solid surface, it still doesn't affect the rate of reaction. Do you understand? Just like you, okay, like you are going to find some girls to have a chat. Okay, you cannot reach that. You just stay always in Chazawan. You cannot the only thing that you can do is to come closer to one girls' school in Chazawan. But even though you do so, you cannot reach the girls in Saigon. You cannot reach the girls in Sati. Can you get what I mean? Okay.
Yes.
Because it's too far from you. Okay. Again, for the reaction to happen, that happens to the surface. So even though the volume of the exit, I still have a change of it. As long as the concentration doesn't change, it doesn't affect you. Okay, what do they have is the more particles just beyond your scope. So, but your focus, the area of focus is on this part only. Just like girls in other countries, even though there are so many girls in other countries, you still cannot reach that. Again, the reaction can only happen on the surface. Okay, don't bother too much about the girls in Europe or in USA, please. So, do you get what I mean? Okay, so this is what I do hope it will clear your doubts about this part. Any questions so far? Any questions so far? Now, so go back to, in case we have got this concept, and you may get to know more about the collision, right? That is from particle viewpoint. So go back to the collision theory furthermore, because I found it's now 11:23. I would like to mention something more about that in particle viewpoint. Now, a collision is said to be effective if two conditions has been met. Firstly, is on the particle collide with the correct orientation, the direction, the angle of hitting, angle of collision. While the second one with the collide with sufficient energy for the bonds to break. So the bonds to break, it relies on the how fast the chemicals that are moving, right? So it processes Ke. While the kinetic energy, do you still remember that one? It tells you that that magnitude, it depends on the how fast or how slow it is. So we call the activation energy. So for the reaction for happen, you are going to break the bond, okay? While that breaking bond requires energy, while the energy comes from how fast moving the chemical it is. Whether or not that Ke should be equal or greater than the activation energy. Okay, so it is your capital, okay? In case you have got enough energy, so it will help break the bond. So that's why I've just said before, that happens for the faster moving particles instead of smaller moving particles. If it runs fast enough, you have got enough kinetic energy, will have transfer, right, to something else to break down the bond, so as to let the reaction go. So it is highly needed because it is used to overcome the repulsion between the electron cloud particles to start rearranging the bonds to form the product. Okay, can you get my point? So go back to the concentration. Why does the increasing concentration of the reactant increase the rate of reaction? Why? At the molecular level, so you are going to find out the rate of the reaction depends on two factors. One is how often the particles, they will hit one another. And second, the percentage of the collision have on kinetic energy equal to the greater than the Ke. So it is what you may know it as the number of collision. For the first cases, while the second cases, it is the number of effective collisions for the second case. So which one will lead the reaction go faster? We mentioned it on what? Number of effective collision mainly. Okay, only by, even though you have got so many collisions, but they are not successful, that is no use. Okay, can you get what I mean? So if you want to talk about the reaction between a solid and a aqueous solution, they will involve a collision between the particles and responsible mainly for hydrogen ions. And once the reaction can go, increasing the concentration, which means that the increasing the number of hydrogen ions per unit volume. Okay, so the hydrogen ions become more crowded, so they would have a higher chance to collide with the particles at the surface of calcium carbonate. So we have got the chance of collision increases. So of course, there will be more effective collision in the unit volume per unit time. So the rate of reaction increases. So what does mean by that? Which means that if you are having a U, right, you will want to meet more girls. Okay, remember to come closer to the girls group. That's it. Done. I didn't tell you whether or not you have increased yourself, your performance, your quality. I just tell you what is the chance. The chance should be go to some closer to your girls groups. Let them just get to know the school ending time, just wait outside while the girls come, okay, leave the school, but you will have a more chance to meet them. That's it. That's it. Okay, can you get my point? So, if you want to talk about gases, the reaction of gases, increasing the concentration of it also will affect the chance of collision as well as the chance of effective collision. It's because both of them, they have become closer, just like this graph. So they, of course, they will have a more chances to collide each other. They will have a more number of the effective collisions. They have more effective collisions per unit volume per unit time. So that's why the concentration of the chemical plays a role. So in short, it would be nice to us to write down certain logical flow. Okay, so what's mean by that? The concentration, all of the, please back down. The concentration of the reactant particles, which will affect, okay, now this one, pressure also plays a role, okay, would be that, okay, I put it here first of all. Concentration of reactant particles increases, okay, that would affect the number of reactant particles. Now, reactant refers to what is AQ, okay, remember, for solid, no such concept. The constant number of reactant particles per unit volume increase, okay, which will affect the what? They will affect what? Closer, crowded, more crowded, and become closer to other reactant particles. Can you get a point? So, which means that they would affect the number of collisions increase. They will also affect of number of effective collisions increase. So this one will affect the rate of reaction increase. Do you understand? So this is our flow of answering the questions. Do you understand? But one thing I would like to mention with you is the number of effective collision, because you want to talk about rate. So add more sentence on this. In a unit volume per unit time. Now, only by having the time concept, we will get to know more about the term rate of reaction. Do you understand? Do you understand? Please remember the flow. So this is what we talk about collision theory. Any questions so far? Now, before you end up the lecture today, please let me know your level of understanding from 0 to 10. And write in the chat box, and you get to know more, right? Now, you may find the collision theory a very important foundation. If you study something more about that, you may get to know the reason behind. Now, remember, what we have just mentioned is just affect the rate of reaction, but the total number of moles of the product to be formed, you just go back to the calculations. So go back to the volume and concentration of exit. Would you start to know how does it affect the number of moles of a product to be formed? They just tell you how fast the product will be formed, but not tell you how much the product will be formed. Do you understand? Do you know the difference between the two terms? How fast, which means the speed, okay, but how much you talk about amount. So in this chapter, what we have just mentioned is talk about the speed. Okay, questions? So I will post the video about the collision theory shortly. Please spend some time on watching this this afternoon, such that you may get to know more about the concept while we meet in the next lesson. Okay, today is Wednesday, right? So you may meet each other Friday to get to know more about the collision theory and use this concept to relate to the other factors. Okay, what we have just mentioned is surface area as well. Okay, you will not get to know this in the next lesson. Okay, any more questions? Okay, if not, I would like to double check attendance again. Ho Chiu-wan, are you here? No? Now, if not, you may now be dismissed. Goodbye.
Bye bye.
Bye-bye.
Bye
Bye-bye.
bye. Bye bye.
Bye. Bye, guys.
Bye bye.
Bye.